Today we're working on linear, exponential, or quadratic. So here are 4 different functions. We need to figure out what the pattern is for each one, and I'm going to show you how to use your calculators to figure out what the equations are. So, shame on you. Okay, so the first one. The patterns we're going to look for in this class are the differences, so the first difference, second difference, third difference, and so on. Or exponential is we're going to use division and find out what you multiply by every time. So for this first box, what is the difference between 20 and 170? Negative 30. And then the next one is negative 30, and then negative 30, and all of those are negative 30. What type of equation is that? Linear. Okay, so down here, question number 1, how do you tell if a function is each of the following? How do you tell if it's linear? Constant first difference. So the answer to the first part of question 1, linear has a constant first difference.
How is not negative 30?
Each one drops by 30. 200 minus 30 is 170. 170 minus 30 is 140. Okay, so everybody turn your calculators on. Okay. So yes. Oh, I thought you did. Yeah, go get it. Oh. Oh. Sorry. Yeah, go get one. Okay. We are going to use our calculator to figure out what the linear equation is. It's your job to find out what type of equation it is. Okay, and I know these calculators are new, so pay attention, ask lots of questions. We are going to start by pushing the stat button. And I push buttons all the time, and people say, wait, what button did you push? The last one I pushed turns red. So watch this. Stat. Now, it's the red one. So everybody push stat. In the stat menu, there are 3 columns. Edit is the button you use if you want to put information into the calculator. Calc is what you use if you want to figure out what one of the equations is. And tests is something that statisticians use. We're not going to worry about it. So push enter on edit. And everybody raise your right hand. Repeat after me. I solemnly swear that I will never push delete. And that I'll bring cookies to Mr. White on Tuesday.
Hey, no.
Oh.
Mr. White is trying to
Okay. So you are now sworn in. Never, ever, ever push delete in the edit menu for stat. If you push delete, you will delete the list and the other lists will slide over and fill its place. If you delete the list, then we have to reset your calculator. You want to push clear. Okay? So I have a bunch of numbers in my L1 and L2. Make sure that you have L1 and L2. If you're missing L1, somebody broke their oath last year and forgot to fix it. No oath breaking. So we're going to go over to L1, and you can see L1 down here, 0, 1, 2. If you push delete, you will get rid of L1. It will disappear, and L2 will fill its place. If you push clear, then L1 is cleared, and if you push enter, now all the numbers are gone. Okay, don't break your oath. Push clear, not delete. And then we'll go over to L2 and push clear, enter, and so on. Start again. So, for a linear equation, how many points do you need to guarantee that the graph you're looking at is a straight line? And it's kind of a tricky question, because if I had 1 point, how many lines are there that go through that 1 point? Lots, infinite. Okay? How many points go through, or how many lines go through both points? Just one, but If all I have is 2 points and I haven't seen anything else, can I guarantee that the only graph that fits is a straight line? No. So you actually need a third point to figure out what it is. Once you have 3 points and they're all in a straight line, that's the only thing that could fit. Okay? And you can actually see that over here. If all I had were these two and I calculate negative 30, does that guarantee it's linear? No, I need to check and see if the next one is also negative 30. So when I throw in this point and I get the second negative 30, can I guarantee it's linear? Yeah, as long as it keeps going negative 30, negative 30. And I'm going to try to trick you later on. I do. I'm tricky. All right, so the question I asked you is a little bit misleading. You need 3 points to figure out what it is, what type of equation it is, but you only need 2 points to figure out which specific linear equation it is. So in your calculator, you don't have to enter all of the points. If you already know it's linear, any 2 points will be enough. Okay? So on your L1, pick 2 points. L1 will be the x's, L2 will be the y's. I'm just going to use 0 and 1. So 0, enter, and 1, enter. And then we go over here. And you have to make sure that you put the corresponding y's. So 0 is matched with 200, and 1 is matched with 170. So 200 and 170. Once you have the points entered, push stat again. So stat. Now we want to go over to calc. And calc is where we find all of the equations. The one we want is linear regression. Now there are 2 linear regressions, and they're both kind of the same thing. They're just in a different order. We want the one that says ax plus b because we're used to mx plus b. If you pick the other one, it'll give you the right answer. It'll just be in reverse. So I'm going to push number 4. Now, depending on what calculator you have, you either see this screen or you just see linear regression, ax plus b. So if you hit enter, or in this case, you just keep hitting enter until you get to calculate. It tells me the equation is ax plus b, and the formula is negative 30x plus 200. So this equation is negative 30x plus 200. Now, if you put points in to the calculator and you pick the wrong equation, it will usually still give you an answer. It just won't be the right answer. Okay, if you pick the wrong equation, you'll get a wrong answer. It's your job to figure out what type of equation it is. Sometimes you'll put information in and ask, and it'll say error, which means you didn't put in enough information. But sometimes that happens. Okay, next one. Second box. From 6 to 7.8, that's 1.8. And from 7.8 to 10, I don't know what that is. 10.14 divided, or sorry, subtract, I messed up. 10.14 minus 7.8, 2.34. I'm already pretty suspicious about this. If it was linear, then the decimals would work out to be a little nicer. I'm going to go out on a limb and say this is probably exponential, which means we're multiplying by the same thing over and over. How do you test for multiplication? You take any term and you divide it by the one above it. So I'm going to take 7.8 divided by the one above it, which is 6, and I get times 1.3. It says 1.8, but we're not using it. Sorry, we decided it didn't work. Yeah. So 1.3. Let's see if timesing by 1.3 works. So 6, we're going to multiply by 1.3. Obviously, it works the first time. Times 1.3. Did it work the next time? Yes. And the next time? Yes. 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 So that's it. So the pattern here is multiply by 1.3. What type of equation is that then? Exponential. So we circle exponential. And then down at number 1, how do you know if an equation is exponential? What's the pattern? It's the same multiplication, but we call that common ratio. It's not a common difference, it's a common ratio. Difference is for addition and subtraction. Ratio is for multiplication and division. So common ratio. All right. Fourth box. Let's do the subtractions here. So 387 subtracted from 425, and I end up with negative 38. That is my first difference. Let's try the next one. 331 subtract 387, and I get negative 56. 257 subtract 331, negative 74, and go ahead and do the rest of those. So negative 73 minus 55. The last one I get 128. Is that linear? Sorry, you guys confused? So all I did was took every number and subtracted the one above it. So we create the first difference. That's what first differences are. You take any y value and you subtract the number above it. And that tells us how much the first one differs from the second one. Okay? Now, once we have all of those, now we need to find the constant, now we need to look for the second difference and see if it's constant. So how far is it? Oops. How far is it from negative 38 to negative 56? Not 18, it's negative 18. We're going down. So my second difference is negative 18. How far is it from negative 56 to negative 74? Negative 18 again. That's a good sign, right? And you'll notice they're all negative 18. And remember, it's always any value, subtract the value above it. Okay, so what pattern is this? Quadratic, circle quadratic. And then on question number 1, how do you tell if a pattern is quadratic? Constant second difference. That's the answer. Constant second difference. Okay, and we learned something about the second difference. Whatever the second difference is, if you cut that number in half, you get the number that goes in front of the x squared. So this equation is something x squared. If you want to know what that something is, it's half of that number. So it should be negative 9. There is a trick with quadratics, though. How many points do you need in order to write a quadratic equation? Well, if we go back here, is 1 point enough? How many parabolas go through that point? A lot. Okay. What about 2 points? So here's a parabola, here's a parabola, there's a parabola. There are actually an infinite number of parabolas. So in order to narrow it down to a single parabola, we need the third point. Any third point will work. If you say this is point 3, then there is only one parabola that hits all 3 points. How many points do you need to figure out if it is quadratic? You actually need 4. So if you look over here, are these two numbers enough to check second differences? No, you can't get any second differences if all you have are 2 points. If you have 3 points, is that enough to get second differences? It only gives you 1 second difference. Is 1 second difference enough to determine quadratic? No. So in general, the number of points needed to write an equation is always 1 fewer than the number of points needed to figure out what type of equation it is. So for a quadratic, it takes 4 to figure out what type it is, and 3 to figure out exactly which equation you're looking at. Okay? And I tell you that because we want to know what the equation is, so we go to Stat, Edit, and let's figure out the quadratic equation, but I need 3 points. So I'm going to use 0, 1, and 2. And then I go over and enter 425, 387, and 331. Oh, shoot. Sorry, 1 and 2. There we go. Anybody having trouble putting those in? So go to Stat. Oh, you're right there. Okay, so 0, 1, and 2, and then 425, 387, and 331. Anybody else having trouble? So you need to put a 2. So 2. And then put in those 3 numbers. These 3. 425, 387, 331. Anyone else? Once you have those entered, push Stat again. Stat. Go over to Calc. And this is a little bit tricky. There is a quadratic regression and a quartic regression. Quadratic is x squared, and quartic means x to the 4th. Don't mix those up. So don't push number 7, push number 5. We want quadratic regression, number 5. Keep hitting enter, or depending on your calculator, you might only have to hit it once. And it says the equation is ax squared plus bx plus c, and then it tells you what a, b, and c are in this particular case. So negative 9x squared minus 29x plus 425. That is the quadratic equation for that table of values. So push quadratic regression number 5. And then go down to calculate and hit enter. You can just keep hitting enter. It'll go down. Oh, you have the silver edition. That just means that's the percentage of how accurate it is. So it's 100% accurate. These are actually regression lines. So if you throw up a bunch of random mixed up dots, it will draw the equation that is as close as possible, and then it will give you the percentage, saying this is only 80% accurate. But when you only put 3 dots, it hits all 3 of them. So it's 100% accurate. Okay, anyone else need help? Did you not get it? So go to Calc, and then quadratic regression. And then just keep going. There you go. Oh, your data is mixed up. So you didn't put 331. There you go. Okay, anybody else? One thing we forgot to do, we didn't do the exponential regression. So back to the second table. How many points do you need for an exponential equation? And the answer is just 2. So going back to this chart here, push Stat, go into Edit, and clear out your lists. We don't need those lists as big anymore. and then pick any two of the exponential. It's usually easiest to pick the first two. So for your x's, put in 0 and 1, and for your y's, put in 6 and 7.8. Okay, and then to find the equation, push stat and go to calc. So stat, calc, and you have to go down quite a ways to find exponential. It'll say EXP regression, and I believe it's number 0. So if I just push 0, it should skip right to it. And then go down to calculate. And it says the equation is a times b to the x, and a is 6 and b is 1.3. So the exponential equation is y equals 6 times 1.3 to the x. Okay, I'm going to pause the video in just a second. I want you guys to do the differences on the next chart. And just keep doing the differences until you find one that matches. So for that last chart, go through, find all the first differences, and all the second if necessary, and third and fourth, however far it takes to find the common difference. So I'll pause the video. You guys work on that. And then we'll talk about it. So once you fill this out, you get down here, and these should all be 24. So is this linear? No. Is it exponential? No. Is it quadratic? No. Then what is it? None of the above. More specifically, this one would be an x to the fourth because the fourth difference matches. So if you wanted to know what the equation is, you'd put in a bunch of points. In fact, you would need 5 points. You need one more point than the exponent in the equation. So for an x to the 7th, you need 8 points. For an x to the 11th, you need 12 points. For linear, which is x to the 1st, you only need 2. For quadratic, which is x squared, you need 3. So if you entered 5 points in there and did a quartic regression, it would tell you the x to the 4th equation, which I don't know what it is. Don't worry about it. So on number 1, it says larger than quadratic. The number of the difference tells you the exponent. What that means is fourth difference is x to the 4th. Fifth difference is x to the 5th. So the number of the difference matches the exponent number. Then your assignment for the rest of the day is to look at graphs and equations and tables of values and figure out what sort of pattern are you looking at. But you have to be careful. You can never trust a graph. Is that a quadratic? Maybe, but it could be part of a larger graph that's not a quadratic. So you can't trust a graph, you can only trust the numbers. For instance, is this exponential? Maybe. But it could also be part of a parabola. So you can't look at a graph and say, oh, that's quadratic. You need to look at the numbers. So if you take a look at number 2, that looks exponential, right? But it could also be quadratic. So let's check the y values. What's the first y value? 1. What's the second y value? 2. And the next y value? 3. And then 5. And then? This looks like 17 to me. So if I put that in a table, my x's I don't really care about. My y's are 1, 2, 3, 5, and 17. Oh, there's no 3. Sorry. 1, 2, 5, 10, 17. Oh, I messed that up. I'm sorry, guys. So the y values are 1, 2, 5, 10, 17. Thank you. First differences. What are the first differences? Plus 1, plus 3, plus 5, plus 7. Is that linear? No. But plus 2, plus 2, plus 2. Therefore, this is quadratic. Even though it looks exponential, it's actually quadratic. How would we know it is exponential? Exponential would be something like this. 2, 4, 8, 16, where we times by 2. Okay? Look at number 3. Do you see a pattern in number 3? Subtract 6. So it says you need to explain, so be sure to explain. The pattern is subtract 6. So this one is linear. Okay? And number 4, we have to do a little bit of math here. We have to times these together. So I get y equals 4x plus 6x squared. What type of equation is that? Linear, exponential, quadratic, or none of the above? Quadratic, how come? The biggest exponent is x squared. Okay? The largest exponent determines the shape of the graph. And in this case, it's x squared, so this one's quadratic. Okay, your assignment today, turn that over. Look through those. Some of them are really tricky. Determine linear, quadratic, exponential. And again, without the numbers, you can't tell. You have to check the numbers. Okay? That's due tomorrow. Good luck.